Question. For how many integers n between 1 and 2018 inclusive is the unit digit of n to the power of 2018 equal to 6? Before attacking this problem, let's think about what the problem is asking for. When we are raising n to the power of 2018, we are only interested in the units digit. This information is useful because the units digit is not affected by the tens, hundreds, thousands, or etc. digit because there is no need to carry an extra number which will affect the units digit. For instance, let us compare the units digit for 13 to the power of 3 and 3 to the power of 3. 13 to the power of 3 is equal to 13 times 13 times 13, which is equal to 169 times 13, which is equal to 2197. 3 to the power of 3 is equal to 3 times 3 times 3, which is equal to 9 times 3, which is equal to 27. Notice how the units digit remains the same, despite both numbers having different digits in the front. In this case, 13 has a tens digit, while 3 does not, and yet they still have the same units digit. This leads to a critical observation. We only need to consider the units digits from 0 to 9 and check if raising each of these digits to certain powers will have a units digit of 6. I know that sounds confusing, so let's start a case-by-case testing procedure for each digit. 0 will never have a units digit of 6 whenever it is raised to any power, because 0 to any power is still 0. 1 will never have a units digit of 6 because 1 to any power is still 1. 2 will have a units digit of 6 after every fourth power. The pattern is 2, 4, 8, 6, and then the units digit repeats back to 2. Note that these are not the exact answer for raising 2 to a certain power, but just the units digit. 3 will never have 6 as a units digit, as the pattern is 3, 9, 7, 1, 3, and then repeat. 4 will have 6 as a units digit every even power, as the pattern is 4, 6, 4, ... 5 will never have a units digit of 6, as 5 to the power of anything will always have a units digit of 5. The pattern is 5, 5, 5, and so on for the units digit. 6 will always have a units digit of 6, no matter what positive power you raise it to. The pattern for the units digit is 6, 6, 6, and so on. 7 will never have a units digit of 6, no matter what power you raise it to, as the pattern is 7, 9, 3, 1, 7, and then repeat. 8 will have 6 as a units digit every fourth time, as the pattern is 8, 4, 2, 6, 8, and then repeat. 9 will never have 6 as a units digit, as the pattern is 9, 1, 9, and so on. Let's look at our table. The only digits we want to consider are 2, 4, 6, and 8, as none of the other units digit will yield a units digit of 6 whenever we raise it to a certain power, or in this case 2018. So the only digits we want to consider are 2, 4, 6, and 8. However, we have to make sure that when we raise these digits to certain powers, it still divides evenly into 2018. For example, if I was raising a 4 to a power of 3 and checking if it has a units digit of 6, then obviously this doesn't work, because 4 cubed is equal to 64, and the units digit of that is 4, which is not 6. In order for 4 to have a units digit of 6 after we raise 4 to a certain power, we have to make sure that the power is still even. And in this case, 3 is not even, so it contradicts what we have said. For every digit, we have to make sure that the constraints we have set will still work for 2018 as a power. Let's start with the units digit of 2. Remember, we have said that every fourth power will have of 2 will have 6 as a units digit. So we have to make sure that the remainder of 4 divided by 2018 is equal to 0. However, in this case, the remainder is 2. So 2 does not work as an answer. For 4, we've stated that every second power will have 6 as a units digit. So we have to make sure that 2018 divided by 2 gives a remainder of 0. And in this case, it does. For 6, we stated that it always gives a units digit of 6, which is the equivalent of 1. So we have to check if 2018 divided by 1 yields a remainder of 0, and obviously it does. 8 will yield us the units digit of 6 after every fourth power, and 2018 divided by 4 gives a remainder of 2, which does not work. So the only two numbers we have to consider are 4 and 6. This comes to because we only have to consider these two digits in particular, we can rephrase what our problem is asking for. We have to compute how many numbers have 4 or 6 as a units digit from 1 to 2018 inclusive. We have this question because, after going through all this work, we have come to the conclusion that only 4 and 6 work as units digits, so that when we raise it to a power of 2018, it will give a units digit of 6. And no matter what other numbers we keep in front of 4 or 6, it will still have a units digit of 6 after raising it to a power of 2018. Our question was, how many numbers from 1 to 2018 have 4 as a units digit? Or have 6? We can calculate this value using some simple arithmetic. Let us pretend that these lines represent the digits of a 4-digit number. In this case, we have to fix this as either 4 or 6, so let's start with 4. For 1-digit numbers, the only answer is 4. For 2-digit numbers, we can put 9 numbers into this box, which are 1, 2, 3, 4, 5, and so on, all the way up to 9. We can't put 0 in here because that would result in a 1-digit number. So for 1 digit, there is one way. For 2 digits, there are 9 ways. And for 3 digits, the number of digits we can put in this box for 3 digits now becomes 10, because we can put a 0 in here, but we still have to restrict this box. So we can put 9 digits here, which is the same thing as 1, 2, 3, 4, 5, 6, 7, 8, 9. And we multiply these two, so we get 90 ways. Finally, for 4-digit numbers, since we're only considering up to 2018, let's first consider if the first digit was 1. Then, this is the number of ways if from 0 to 1000. Now we must consider the amount of numbers from 2000 to 2018 with a units digit of 4. In this case, there are only 2 numbers. Those are 2004 and 2014. So let's add 2 from these two, plus 1, plus 9, plus 90, plus 100. Our answer is 202. This is the amount of numbers with the 4 as a units digit. And if you think about it, this would actually be the number of numbers for 6 as a units digit, because there are no constraints limiting 4 or 6 as a units digit. So we can simply multiply this by 2, and that becomes 404 numbers. Thank you for listening.